Okay. This is lab 1 for physics 2212, called charge tapes. The purpose of this lab was to determine the excess charge on a piece of tape, and to observe the transfer of electrons between the two items. The overall results of this lab showed that the charge on the tape was negative 1.353 times 10 to the negative 8th coulombs. One of the physics laws that was important for this lab was Coulomb's law. This law states that the electric force is equal to the K constant times the charge of the first item times the charge of the second item, all divided by the distance between those two objects squared. Another important physics concept that was utilized in this lab was Newton's third law. This is also known as the law of reciprocity. The procedure of this lab began by creating two negatively charged U-tapes by quickly pulling them off of the base tape. The second step was to orient the two charged tapes so that they repel from each other and the top piece of the tape hovers above the bottom one. The final step of the procedure was to record the distance between the two tapes in order to complete the calculations. There were three main assumptions made before beginning the lab. Number one was that we assumed each piece of tape could be treated as a single point charge. The second assumption was that the charges were evenly distributed along the piece of tape. And the third assumption was that we assumed that air resistance was negligible in this scenario. For our measurements, the length of the tape was 0.2 meters. The mass of the tape was 0.0002 kilograms. This was found by multiplying the length times the mass per meter, which was 0.0001 kilograms per meter. And then the distance between the two tapes was 0.029 meters. For the calculations, this was done using Python and GlowScript. At the top of the slide is the code that was used, and then below the code is the output that the code produced. First, we found that the force from the gravity, which was just the mass times the gravitational constant, then we were able to use reciprocity, or Newton's third law, to determine that the electric force from the other tape would be equal to the negative gravitational force. And then finally, we used Coulomb's law to find the charge of the tape. The charge of the individual tape strip is found at the very last line on the slide. For the next part of our calculations, we wanted to figure out the excess amount of electrons on the piece of tape. So we started by finding the surface area, and then we found the number of atoms by dividing the surface area of that tape by the area of the single atom. To find the number of excess electrons, we divided the charge of the tape by the charge of a single electron. We found that there are about 4.49 times 10 to the 17th atoms on the sticky surface, 8.46 times 10 to the 10th excess electrons on the sticky surface, and that the ratio of excess electrons to the atoms on the sticky surface is 1 to 5.3202 times 10 to the 6th. And then you can see the ratio at the very last line at the bottom of the slide. So here's the GlowScript diagram model of the scenario. In this case, each of these blue dots represents one of the pieces of tape. The red arrow symbolizes the gravitational force that points downward, and then the two green arrows represent the respective electric forces. As you can see, the green arrows do repel each other in this scenario because they're both negative and like charges repel. For the reflection, if the electron had a positive charge and the proton had a negative charge, there would be no change in the results of this experiment because the like charges will still repel each other and the opposite charges still attract each other. Therefore, we're going to end up with the same results with the hovering behavior. It's important to handle the charged tapes as little as possible because our hands are neutral objects. So the more that they interact with the negatively charged tapes, the more electrons are going to transfer into the hand in an attempt to reach equilibrium, and that will cause the tapes to be neutral. Therefore, we will not have the same results with our experiment. And that is the end.